Welcome back everyone, Patrick here, moving on to the next video, more factoring questions. And in this particular video, basically all of these questions here, they're gonna have some kind of greatest common factor that we have to take out. And then after we take out that greatest common factor, we're gonna be factoring by decomposition, where the case of the A value is not going to be 1. So just wanted to give a heads up about that. So let's start off with part A. We have 27x squared minus 27x plus 6. So notice in this case between the 27, and the 6, what's a common factor? 3. We could take out 3 from everything, and notice we'd be left with 9x squared minus 9x plus 2. Like that. And then let's see if we can further factor that bracket that is remaining. So the A value is 9, the B value is -9, and then the C value is 2. And then the AC value is going to be 2 times 9, which would give us 18. So then we got to find two numbers that multiply to 18, add up to -9, like that. And the two numbers would be what? -6 and -3? -6 times -3 gives us positive 18, and then -6 plus -3, which is like -6 minus 3, gives us -9. So then we decompose this middle term over here into those two values. From these two, we could take out a 3x, so we'd be left with 3x minus 2. And then over here, notice there's a negative here, so we're definitely going to take out a negative at least, and then between 3 and 2, there's no common factor there. So we would actually just take out a -1 from these, and then notice just all of the signs would change as expected. We can then take out that binomial common factor, and we're left with 3x minus 1. So this bracket here factors into those two brackets. If you want to check your answer, you could take that, expand it. If you do expand it, you would end up with that. So the final answer ends up being that 3 that we took out initially, 3x minus 2 times 3x minus 1, like that. Moving on to part B, notice in this particular case, all of the terms actually contain an x variable, right? So we could definitely take out an x variable from all of these. Now in terms of the numbers, notice there's a negative here in front, so we're definitely going to take out a -1 at least, but between the 6, 16, and the 6, notice we could also take out a 2 from all of those. So overall, we're going to take out a -2x. Right? X to the power of 1. Sorry, I didn't mention that because we have 3, 2, and 1. And if a variable is common in all the expressions, as we've shown in previous videos, we always take out that variable to the lowest exponent. And the lowest exponent in this case is 1. So we're going to take out -2x from all of these over here. And so what would we be left with in the brackets? Well, we could just take all of these and divide it by -2x. So -6 divided by -2 would give us 3. X to the 3 over x to the 1 gives us x squared. -16 divided by -2 gives us positive 8. X to the 2 over x to the 1 gives us x. 6 divided by -2 gives us -3, and then the x's cancel out like that. And so notice that we started with a cubic function because we have this x to the 3, but once we factored out that -2x, we end up with a quadratic in the brackets. And so from here, let's see if this quadratic will factor further. It might not, but let's see if it does. So let's write out the A, B, and C values as usual. The AC value is -9. Find two numbers that multiply to -9 and add up to that B value of 8, which would be what? -1 and 9? Right, -1 times 9 gives us -9, -1 plus 9 gives us positive 8. So then we decompose that middle term into those two terms. From these two, we could take out an x. Then from these two, we could take out a 3. And as expected, that bracket is the same. Remember, if that bracket is not the same, then you got to go back in your factoring process. Something is off, right? So this bracket here factors into those two brackets, and we still have that negative 2x in front. So the final answer here ends up being negative 2x, and then those two brackets, 3x minus 1 times x plus 3, like that, right? So sometimes be on the lookout. You're going to maybe take out variables as well in terms or in addition to certain numbers you'll take out. And then part C, this is going to be another one of those scenarios. So notice between the 30, 33, the 18, a common variable between those would be what? 3. You definitely take out a 3 from all of these, but notice that we have an x variable that's common in all of them. What would be the lowest exponent? It would be this x to the 2. So we could definitely take out x to the 2. And then notice that y is common in all of them too, just y to the power 1. So we could definitely take out that y as well, right? So in this particular case in part C, the greatest common factor we're taking out, it's a little bit more complex. It's a multivariable common factor we're taking out. But let's see what we would be left with. So what we would do is we would basically divide all of these by what we're taking out. So this 30 divided by 3 would give us 10. The y's cancel out. X to the 4 over x to the 2 gives us x to the 2. Then we got this minus over here. And then 33 over 3 would give us 11. X to the 3 over x to the 2 would give us x, and then the y's cancel out. Then we got this minus. 18 over 3 gives us 6. X to the 2 over x to the 2 cancel out. Y's cancel out. So we end up with that right there. And so again, we end up with a quadratic in the brackets. Let's see. If it factors. So we end up with that. Are there two numbers that multiply to negative 60 and add up to that b value of negative 11? And the two numbers would be negative 15 and 4. Negative 15 times 4 gives us negative 60. Negative 15 plus 4 gives us negative 11. Decompose that middle value, or that b value, into those two, and then factor by grouping. From these two, we could take out a 5x, and we'd be left with 2x minus 3. From these two, we could take out a 2. Again, left with 2x minus 3. And we end up with that right there, 2x minus 3 times 5x plus 2. So this bracket over here factors into those two brackets like that, right? So for part C, we have that greatest common factor we took out, and then we factored that remaining bracket. Moving on to part D, we got negative 56x squared minus 126x plus 35. So notice that in this particular case, we have another case where that leading coefficient is negative, so we're definitely at least going to take out a negative 1 from all of these to make that leading coefficient positive. But between 56, 126, and 35, we can actually take out a 7 as well. In terms of variables, can't take out any variables because there's no x in that last term. So if we take out a negative 7, if we divide all of these by negative 7, basically the sign's going to change for all of these. Negative 126 divided by negative 7 would give us positive 18. And then 35 divided by negative 7 would give us negative 5, like that. Okay, and so from here, let's see if that remaining bracket, that remaining quadratic will factor. Now, a lot of times, maybe not a lot of times, but sometimes this remaining quadratic won't factor further, right? When you do the decomposition process, you won't be able to find two numbers that multiply to that AC value or add up to that B value. And then in this case, in that particular case rather, the answer would just be that right there, right? You would just factor out the -7. However, in this particular case, I think that this will factor. So let's see two numbers that multiply to -40 and then add up to the b value of 18. And those two numbers would be what? -2 and 20? Right? -2 times 20 gives us -40. -2 plus 20 gives us positive 18. And so what we do, decompose like that. From these two, we could take out a 2x. Then from these two, we could take out a 5. And then we could take out that 4x minus 1, and we're left with the 2x plus 5, right? Remember, we took out that -7 initially, and we're left with 4x minus 1 times 2x plus 5, like that. All right, moving on to part E. This one's a little bit more complex. Another one of those multivariable expressions. So we got 20x cubed y plus 35x squared y squared minus 75xy cubed. Right, so more going on here. Now let's start with the numbers. 20, 35, 75. Common factor between all of those is 5. Notice there's an x in all of these. Lowest exponent would be that x to the 1. And then there's a y in all of these as well. Lowest exponent, y to the 1. So we're taking out a 5xy from all of these expressions. And so what we do to see what's remaining in the bracket, if your factor you're taking out is a little bit more complex, like in this case, I recommend just dividing each of these separately so you get the correct expression in the bracket over here. So 20 divided by 5 gives us 4. X to the 3 over x to the 1 is x to the 2. The y's cancel out. Plus 7. X to the 2 over x to the 1 gives us x. Y to the 2 over y to the 1 gives us y to the 1. -75 divided by 5 would give us -15. The x's cancel out. Y to the 3 over y to the 1 gives us y to the 2. Like that. Okay, and so from here, what we got to do is let's see if this remaining bracket here is going to factor. So notice it's a multivariable expression. Okay, but even these kinds of multivariable expressions, as we've shown in videos before, these can potentially factor. So notice the a value would be 4, the b value is 7, the c value is -15. So the ac value would be -60. So are there two values that multiply to -60 and then add up to that b value of 7? And there would be two numbers, right? -5 and 12. I think that works. -5 times 12 gives us -60. -5 plus 12 gives us +7. So then we could decompose that middle term. Now be careful with the variables here. Don't forget those. Okay, we've done a bunch of questions factoring this type of stuff. So when I'm doing this, I'm doing it a little bit quicker because I'm assuming that you've watched those videos before. So from these two, notice that we could definitely take out an x, can't take out a y, and then 4 and 5 can't take out any number. So we're just taking out an x, so we end up with 4x minus 5y. Then from these two, 12 and 15, we could definitely take out a 3, and then we have a y to the 1, y to the 2, we could take out a 3y. So what would we be left with? 12xy divided by 3y would give us 4x. -15y squared divided by +3y would give us -5y. Like that. This bracket is the same. And we're left with that x plus 3y like that. Right? So this one was a little bit more complex, right? Just because the remaining bracket wasn't just a regular quadratic, it was a multivariable expression. So overall, initially we took out that 5xy, so that's over here, and then we got the 4x minus 5y, and then the x plus 3y, like that. Right, so then we have one more remaining. This one's not bad because it's not a multivariable, though the greatest common factor is going to contain a variable. So let's just do it here. So between 12, 8, and 32, we could take out a 4. Notice there's an x common in all of these. X to the 2 is the lowest exponent. Dividing this, and dividing that. 12 divided by 4 is 3. X to the 4 over x to the 2 gives us x squared plus 2x minus 8. Like that. So that's what we end up with. And then let's see, does this quadratic factor further? So the a value is 3, the b value is 2, the c value is -8, and then the ac value is -24. So are there two numbers that multiply to -24 and add up to that b value of 2? And that would be -4 and 6. -4 times 6 gives us -24. -4 plus 6 gives us +2. So decompose that middle term into those two terms like that. Take out an x from these. And then from these two, take out a 2. And then we can take out a 3x minus 4. And we're left with an x plus 2 like that. Right? But that is just this bracket. Don't forget the 4x squared that we took out initially. Right? So that ends up being the final answer for part F. All right, so just a couple of examples where we have to take out greatest common factor. Sometimes they're going to be negative. Sometimes they're going to be a mix of variables. Sometimes they're going to be multivariable. So just be on the lookout for that. And then always check if that remaining bracket can factor further.